Welcome. This is the BackendBear Podcast, where we discuss anything related to programming, algorithms, and the latest practices in the coding world. So sit back, grab a drink, enjoy it, and let's dig right into it. How's it going, people? Hope you're having a great start of the week. You're filling out that paperwork, you barely have time for programming, and you can't wait for Friday to come in. Yeah, that was pretty much my last week in a nutshell. But anyway, this week we got an interesting topic. We're going to talk about design patterns. On Twitter, recently I put up a poll so you can choose which kind of topic would I cover first. And the choices were solid principles and design patterns. And by a small margin, design patterns won. But don't worry, I'll revisit solid patterns as well as soon as I'm done with this series, which I hope it won't be too long. But anyway, this week we're talking about something that you probably heard about. I don't think there has been an interview in my career that I haven't been asked a question about design patterns. And it's one of those things that you always forget, and you have to, Google it up every time from time to time. And when you're on the interview, you're hoping to God that the only design pattern you know, they'll probably ask you on the interview. But, of course, that never happens. So it's good to know, to have a general idea about design patterns. And they're a useful thing. You might not even be aware that you're kind of using them in your day-to-day basis. Just, when you start becoming aware of them, you'll kind of know how to use them to your advantage. You don't need to know them all by heart. You don't need to memorize them word for word, but it's crucial for you to know how to read them and, how to look for them, how to find them. And that's kind of the basis of this episode. We'll kind of introduce you to the world of design patterns. We're going to break down what are they consisted of and how to read them and how to approach them. Right? This entire episode was based on a book by the infamous Gang of Four, which is Eric Gama, Richard Helm, Rolf Johnson, and John Blisides. I'm horrible with last names, but hope I pronounced it right, but I'm probably done. But just look for Gang of Four, believe me, you'll find it. And it's one of those evergreen books that if you're into object-oriented programming, it will be, good for you to have it in your library. Yes, the entire book was written with C++ in mind, but the same principles apply to any other, object-oriented language. If you learn how to read their graphs, and I think you should pay attention to that. I can't explain it over the air, but when you read the book, just try to figure out how to read those graphs, and that would be more than enough information for you to how to implement them. Keep in mind that, design patterns are more of a meta-knowledge type of thing, or I don't know, how should I put it, like looking at the big picture in a way. That kind of also helped me in my career, and it kind of made me think outside the box. When you start becoming aware of those design patterns, you kind of see a bigger picture. So that's what, like I said, so keep it in mind that it's just kind of like a meta. It's not like you need to implement it this way. No, it's just a suggestion. And you will be surprised that you kind of implemented, certain design patterns without even knowing it, being aware of it. When you're aware of them, you will develop, for the problem and not the way around. So the problem will not force you to develop a certain way. You will develop for that problem to solve that particular problem. And that's kind of the basis of the entire book. That's basically, the experiences of the other developers and how they solve particular problems. You might find it useful, you might not find it useful. There are other alternatives, different design patterns. You can even design your own design pattern, right? But all of that kind of boils down to those core design patterns that they kind of started off. That's why they're so beloved in the development community, and at the same time hated because, like I said, there isn't a job interview that I haven't been asked that question. So, and you're just hoping that that particular design pattern that they would like to hear about or not. So personally, I read the book at my university days. I did some reading now, of course, brush up my skills for this episode. Usually for my purposes, I use the dofactory.com. They have the the basic design patterns and their implementations in C# and .NET, and that kind of gives me a quick overview. I just need to glance over and remember it how it went, and I was like, oh, okay, and then I can implement it on my own. So that's why I said you just use it as an advice, not as an actual thing, that you have to implement it a certain way. You just need to be aware of them. And when they ask you on an interview, yes, I'm bashing the interview questions, but when they're asking you on the interviews, they're not asking you to do a full implementation. If they are, I don't think that's a good job for you, honestly. But usually they, want you to be aware, to know what the design pattern is, and how to implement it in a simple way, in a few words, and not do a full run test implementation. Maybe some bigger places, but I haven't experienced it in my career, honestly. So it was always do you know, I don't know, singleton pattern? Do you know, not singleton, no one has singleton, but do you know, tell me about factory design pattern, or, they're run on the mills, basically. And when I need to get something more complex, then I usually consult the book and look in the book. So, because on the dofactory.com, there's not that many. It's just the basic, design patterns like factory, strategy. I forgot now, so I can't name them all by hand, but there's a small list, right? There's a lot of design patterns that are in the book and go, in more in depth. But also be aware that today there are other design patterns which are kind of combined with multiple other design patterns. So once you read the book and once you realize what the patterns are inside, then, like I said, you'll start seeing the patterns all around. And yeah, I kind of rambled on in this introduction, but I hope you'll enjoy this episode. And then, without further ado, let's dig right into it. So let's start off with what are design patterns? There are a lot of design patterns today, and they're floating around, and new ones seem to be popping out every day, but all of them are kind of revolving around the original design patterns. Today, it's hard to find an object-oriented system that doesn't use at least a couple of these patterns, and some large systems probably even utilize most of them, or all of them. I don't know. But in my experience, there are a lot of design patterns floating around in a system, one system, right? So designing object-oriented software is hard, and designing reusable object-oriented software is even harder, right? You must see what the objects are, then you need to define, the classes, probably define the class interfaces, inheritance, hierarchies. You need to establish relationships between them. So it's not easy, right? You need to kind of piece it all together. And your design should be specific to the problem at hand, but also general enough to address future problems and requirements. So experienced object-oriented designers will tell you that reusable and flexible design is difficult, if not impossible, to get right for the first time. Also, when you're designing and you catch yourself that you're kind of solving multiple problems at once, and you try to pinpoint a design pattern to it, or design your own pattern, like how to solve that problem, you probably need to do some splitting up and refactoring. So you should always try to keep your modules in a way to solve a certain problem. One thing that expert designers and architects and software developers know not to do is solve every problem. But, reuse solutions that work for them in the past. And that's kind of how design patterns came to be. When you start becoming aware of different, patterns, you will find recurring patterns of classes and objects in many object-oriented systems. These patterns solve specific design problems and make object-oriented design more flexible, elegant, and, ultimately reusable. But be aware, these design patterns don't solve every problem. The good thing about the design patterns is that they're kind of modular, so you can kind of combine multiple systems, just like Legos, like fitting them together. Just, you need to envision it in your head, and I'm kind of a visual thinker, so that's, for me, the easiest. So I kind of think of those graphs, and then I just build a bigger graph and more complex, and then I just start coding it. So what is exactly a design pattern? So from the book, it says that each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use this solution 1,000,000 times over without doing it the same way twice. And by the way, this was written by Christopher Alexander in the book A Pattern Language, Towns, Buildings, Constructions, and so on and so forth. And he wasn't talking about, design patterns in software. He was talking about patterns in architecture. But what he says, it's true, and then applies to our, branch as well. It applies to object-oriented programming as well, and it fits really well. Of course, he didn't have the same design patterns, right? He had different problems that he had to solve, but we have different problems that we have to solve. But we can use his system and apply it to our world. So every design pattern is consisted of 4 essential elements. So number one is pattern name, and that's like a handle that is used to describe a design problem, its solutions, and consequences in a word or two, right? Then you have another section, which is the problem. So it describes when to apply the pattern. It explains the problem and its context. It may also describe specific design problems, such as how to represent algorithms as objects. Sometimes the problem will include a list of conditions that must be met before it makes sense to apply them to the pattern. So next section is the third one, is the solution. So it describes the elements that make up the design, their relationships, responsibilities, and collaborations. Pattern is like a template that can be applied in many different situations. Pattern provides an abstract description of a design problem and how a general arrangement of elements, classes and objects in our case, solves it. The last portion is the consequences. And they are the results and trade-offs of applying the pattern. They help you with evaluating the costs and the benefits of applying the pattern. The consequences for software often concern space and time trade-offs. They may address language and implementation issues as well. The consequences of a pattern include its impact on systems' flexibility, extensibility, or portability. The design pattern identifies the participating classes and instances, their roles and collaborations, and the distribution of responsibilities. Each design pattern focuses on a particular object-oriented design problem or issue. It describes when it applies, whether it can be applied in a view or other design constraints, and the consequences and trade-offs of its use. So how do we describe design patterns? So there are multiple ways to describe design patterns. So one would be graphical notation. And like I mentioned earlier, it's kind of a problem to explain it over the air. So I'm leaving it to you, if you're interested, to do some research on that end. So you need to research how the graphs look like, how graphs how to make those graphs and so on and so forth. I'll try to leave some links in the show notes as well so you can follow. I'll probably leave the Do Factory one and anything else I find useful. Or, if you have some useful links for design patterns, I think that's a great idea. So if you have any suggestions, please leave them on Twitter. Send me via email or something. Leave me a good suggestion for a good link where you discover your design pattern information. But like I also mentioned earlier, you should have the Gang of Four book in your library. But besides that, when we need a quick lookup and research, show me some good resources for the design patterns. When reading the descriptions of design patterns, they can be quite large, and there are a lot of things going on there. And there are some terms that, I think they're pretty self-explanatory, but just in case, I'm going to read through them in a quickly fashion, just to give you an overview what you can find in the description of design pattern. So you can find pattern name and classification, right? Then you can find intent, and that's a short statement that answers the following question. What does the design pattern do? What is its rationale and intent? What particular design issue or problem does it address? You have also known as, which is also known as something else. Motivation. It's a scenario that illustrates a design problem and how the class and the object structures in the pattern solve that particular problem. The scenario will help you understand the more abstract description of the pattern that follows. Applicability. What are the situations in which the design pattern can be applied? What are examples of poor design that the pattern can address? How can you recognize these situations? Participants. So it's the classes and or objects participating in the design pattern and their responsibilities. Collaborations. It's how participants collaborate to carry out their responsibilities. You have consequences. Consequences, how does the pattern support its objectives? What are the trade-offs and the results of using the pattern? What aspect of system structure does it let you vary independently? Implementation, what pitfalls, hints, or techniques should you be aware of when implementing the pattern? Are there any language-specific issues? Known uses. Examples of the pattern found in real systems. In the book, you'll find at least 2 examples from different domains. Related patterns. What design patterns are closely related to this one? What are the important differences? With which other patterns should this one be used? I hope I haven't lost you by now with this, listing and enumeration, but as you can tell, there are a lot of things going on inside of a description of a design pattern. So those are some of the terms that you're going to run into. Like I said, most of them are pretty much self-explanatory, but just in case, I kind of went through it so you would have an overview of it. So there are a lot of design patterns out there. In the book, I think there's around 23. I'm not sure. I think it's around 23. And you have to organize them somehow. So the design patterns are classified by 2 criteria. And online and in other resources, you'll see the same classification in those books as well. So everyone accepted kind of this classification. One thing that the Gang of Four book did good is that they managed to put the problem on paper, kind of classify it, explain it, and give a possible solution. So you can apply this concept to any design pattern. And that's what it's really good for. So like I said, there are 2 criteria for classifying design patterns. So the first one is purpose, and it reflects what a pattern does. So patterns can have either creational, structural, or behavioral purpose. So creational patterns concern the process of the object creation, or structural patterns deal with the composition of classes or objects. And behavioral patterns characterize the ways in which classes or objects interact and distribute responsibility. So that's the first criteria. The second criteria is the scope, which specifies whether the pattern applies primarily to classes or objects. So let me put a stop here. So what is the difference between a class and an object? Yes, most of you will roll your eyes, but so hear me out, just to refresh your memory. A class is a blueprint from which you can create an instance of the class, which is also known as object. Objects have physical existence in memory or in runtime, while classes have logical existence. So class design patterns deal with the relationships between classes and their subclasses. Those relationships are established through inheritance, so they're static, fixed at compile time. Object patterns deal with object relationships, which can be changed at runtime and are more dynamic. Almost all patterns use inheritance to some extent. Only patterns labeled with the class patterns are those that focus on class relationships. Most of the patterns, as you will see in the table, and I'll put that in show notes, are in object scope. So in case of a class creational design pattern, the object creation is assigned to some of the subclasses, while in case of an object creational design pattern, the object creation is tasked to another object. So let's say, for example, we take the case of structural class design pattern. It uses inheritance to compose classes, while structural object pattern describes ways to assemble objects. Same can be said as behavioral class patterns use inheritance to describe algorithms and flow of control, where behavioral object patterns describe how a group of objects cooperate to perform a task that no single object can carry out alone. Some of the design patterns are not standalone, and you will find them being used together. For example, composite design pattern is often used with iterator and visitor design pattern. Don't worry about that yet, but we're going to talk more about it in the future. So some design patterns have alternatives. There's a prototype, and that's an alternative to an abstract factory. So both of them kind of do the similar thing, but they solve different problems. So, there's subtle differences, right? Some patterns result in a similar design, even though the patterns have different intents. So, for example, composite and decorator design patterns are similar in design, but they have completely different intents. So, design patterns solve many of the day-to-day problems we as object-oriented programmers face, right? In many different ways. Let's go through some terms. So, when we talk about an object packages both data and the procedures that operate on that data. The procedures are typically called methods or operations. So an object performs an operation when it receives a request or a message from a client. So requests are the only way to get an object to execute an operation. So operations are the only way to change objects' internal data. Because of these restrictions, the object's internal state is set to be encapsulated. It cannot be accessed directly, and its representation is invisible from outside the object. So, what is the hard part about object-oriented design? It is decomposing a system into smaller objects. So the task is difficult because we have to deal with a lot of factors. So just to name some, it's you're dealing with encapsulation, dependency, flexibility, performance, evolution, reusability, so on and so forth, right? And all of those use the decomposition, and often in conflicting ways. It makes me think like how organic programming is. You can never abide by all rules. Code will never be purely clean, but we need to strive to keep it as clean and as reasonable as possible. So we can't make things perfect. We have to cut corners here and there. And we're all aware of that, and we're all doing that, but we always need to strive for a clean and well-designed system. Object-oriented designs often end up with classes that have counterparts in the real world. Strict modeling of the real world leads to a system that reflects today's realities, but not necessarily tomorrow's. The abstractions that emerge during development are the key to making the design flexible. So the design patterns will help you identify less obvious abstractions and the objects that can capture them. For example, objects that represent a process or algorithm that don't occur in nature, yet they're a crucial part of a flexible design, like strategy pattern, for example, which helps you implement interchangeable families of algorithms and change it on the fly. Speaking of which, strategy is one of my favorite design patterns. I used it in one of my Android apps. I think it's still on the market. It's called Anchorman, and basically reads out, it's a text-to-speech news reader. So what I used at the time, strategy design pattern, was based on the URL. I wanted to determine the source of the news. So let's say you have Google News, and yes, at the time I was just HTML parsing the Google News website. And I just wanted a challenge, no particular reason. But anyway, yes, they had the API, but I think even they stopped using the API. But anyway, I'm going on a sidetrack. So so you have different sources like, I don't know, CNN News, BBC, Fox, then you have, Google News. So you have all these different aggregators of news. So I wanted to differentiate between them. So, and based on the URL or based on the source, I wanted to apply a different parser to the website. So that's what I did. I kind of built parsers that use that, strategy pattern and kind of stripped it away. But later down the road, I figured out, I think it's called News API. So there's an entire API that just gives you from whatever source you want, and it just gives you the news, and I'll just swap that and just remove that part. But still, it kind of left a fond memory because, I challenged myself, I did something, and I even improved it down the road. Like, I figured out something better or easier. Like, here's an API key, just, and run the function on it. So it's simple as that. But still, if you ever want to check it out, it's still on the Google Play Store. It's developed in Java, so I'm not going to rewrite the entire thing in Kotlin. It will just be a good memory. The project never kind of left off, but that's another story. My story of woes, if you want to listen to ever in the future, let me know. So I think it would be a good spot to stop for the day, even though the episode is around half an hour shorter than my usual. But I think we crammed a lot of information today, and it needs to kind of digest. So we talked about design patterns. We talked about what are they, how do they define, how do we describe them, how to classify them, when to use them, even my experience implementing strategy pattern in Android app. The takeaway you should take from this whole episode and this whole thing, Gang of Four figured out a way how to explain a problem and the solution to the problem. They figured out a way how to classify that problem. And it would make sense in our, object-oriented programming world. And you should use that to your advantage. Maybe some of these design patterns won't solve your problems, but you'll, solve another problem one day and you wanted to share it with the world. So you have a way of describing that problem. I haven't seen a better way to describe, classify a problem and a solution than the way Gang of Four did it. They sure have put a lot of thought and love in it. You can just tell by reading the book. And that's why I say you should have this book in your library. If you're into object-oriented programming, definitely you should have it. Out of respect, if nothing less, right? It can collect dust, but they deserve it. Thank you for listening to an episode of BackendBear Podcast. Make sure you follow us on Twitter at BackendBear and on Facebook at BackendBear Podcast. If you have any questions or concerns, feel free to send them via Twitter or just email me at marco@backendbear.com. Any other information or anything that you would like to know, it can be found at backendbear.com. Thank you again, and until next time, ta-da!